Yes, ma'am.
Okay. Okay, so now I'm going to share my screen. Deepak, can you mute yourself? So my screen is visible. Okay. Okay. So till now we have covered. Everybody knows that we are following this fourth book. Okay, and I have uploaded the sixth edition version in the Google Classroom, and you can get this online. This PPTs online also, and I will share these PPTs after completing this module one, because sometimes I will change the PPT. So whenever which portion I have to take, I will just see, and if some points are missing, so I will add some points also to make the things very clear. That is why I'm not uploading now, because till now I have not checked all the PPTs that all data are there for explaining effectively. Okay. Okay. This will keep on disturbing me. Kindly join the class as soon as possible. It is like already 10 minutes is over. Okay. So, so till now what we have discussed is database system. What are databases? So mainly in database, we will be storing the data, and how to store the data, how to communicate with this data. We will study in whole through in this subject. Okay, so we will store the interrelated data, and we will have some set of programs to communicate with this interrelated data. Okay, then we have seen some examples also where currently it is being used in, actually we can see in everywhere in every sector we are using DBMS, because every sector is storing the data. So how to store the data in an optimized manner so that we can later on retrieve the data very easily. So we have seen enterprise, manufacturing, banking, universities, airlines, web-based services, document database, navigation system. Everybody is using that. Okay. Then we have seen what are the purpose of the database. So purpose we have seen in terms of whatever we were using previously, what technology we were using previously, that is file system. So what are the drawbacks of file system? In context of that, we have introduced what is the purpose of database. Okay, so if there is some fault or some kind of problems are there, that is why the new things will come into the picture. So how database has evolved, because these kind of problems were we were facing in the file system. So problems were like data redundancy and inconsistency. These all words I have already defined. Actually, in two classes I have defined difficulty in accessing data, data isolation, integrity problem, atomicity, concurrent, and why every time I am emphasizing on those problems, because in whole this subject we will be seeing uh, how to solve this problem. This whole through all through 50 unit, you will be seeing how this redundancy problem I can solve, how this data isolation problem you can solve, how this integrity problem you can solve, atomicity problem. So there are different technologies and set of rules are there, set of programs are there, which are uh, means solving this problem. Okay. Then we have seen one university database. So in university database, which kind of data we will store and which kind of programs we will use. Because mainly the database system has the data and the tools to communicate with data. That is all about the database. So in university, what data we will use? For example, student data, instructor data, classes data, and so on. Okay. And what tools we will use? So add new student, one tool will be there already designed. The tool, courses tool, register student for courses, generate class rosters, and all these tools will be there. Okay. Okay. Now the next one is view of data. So last class we have seen this PPT and we have discussed on this. Now the next one is view of data. So a database system is a collection of interrelated data and a set of programs that allow users to access and modify this data. Okay, so this already we know that we are going to store the interrelated data. Can anybody tell what is that mean of interrelated data? Why every time I'm saying this is interrelated data, interrelated data? What is the difference between a data and interrelated data? Anybody can give any example? Anyone? At least try to give wrong answer. Ashwini, are you there? Ashwini, Gokul Priya, are you there? Harini, Hariram, okay, Hariram, you are there. Okay. Can you tell what is data and interrelated data? Yes, what is interrelated data? O- Okay, means you want to say that data will be connected in somehow with the other data. That is interrelated data. Okay, correct. What about Gokul Priya? Ashwini, are you there? At least say yes, gone. Put in mute and have gone. So the interrelated data, I'll just give one example. If I'll say Siddharth and 19. Siddharth is an one data and 19 is the one data. So what this data we will do means are they interrelated, or if it is related, then how they are related? Like Siddharth and 19, I can say Siddharth has age of 19. Okay, so now with the age we are relating the data Siddharth and 19. Or what I can say, um, Siddharth is living in room number 19. That is also one kind of information. So Siddharth and 19, I am relating with the which room number. Siddharth is living in 19 room number. Okay. So this is the relationship between the data, between two data. Okay. If you will give me Siddharth and 19, what data I can infer, what information I can infer from that. If you will not tell me the relationship between that. Okay. So every time when I say we will store student data, we'll store student data. So it is like if one student data we are storing, so we are storing the contact number, one relationship, the address, the second relationship, the class, which class they are going, this is the third relationship. So these all are the connections between this data, one contact data and with the student. Okay, this is interrelated data. Okay. And we have some tools and programs we have to access or modify this data. That tools and programs we will see. Okay. So, second point is a major purpose of database system is to provide users with an abstract view of data. Okay. So, we have seen in the example in airline booking, airline ticket booking, or train ticket booking, you are using the database. Okay. But you don't know what behind your screen, or if you are booking your railway ticket, what kind of data they are using, what database they are using, how they are giving that, yes, this seat is reserved and this seat is free. You can book this seat or something. How they are calculating this all, you don't know. This is the black box for you. Okay, so this is called data abstraction. Okay, the view of data is like they are only showing that much of data that is useful for the user, that is needed for the user. They are not showing the whole database. Okay. So how these all things can happen? So there are two things, that is data models and data abstraction. So data models, there are so many different data models are there. Okay. So a particular organization will use a particular data models according to their requirement. Okay, so we will see the so many different data models also. So what is data model? A collection of conceptual tools for describing data, data relationship, data semantics, and consistency constraint. So there are some properties are there according to which different data models are there. And the second thing is data abstraction. Abstraction means uh, full complexity you will not show. The everything which is we are manipulating to get the answer, we are not showing you. That is called abstraction or encapsulation. If you have studied C++, then what is the mean of encapsulation? Like behind that or inside that, what is happening, we don't know. We are just enter our data that I want to go from this to this place. So it will show the train, and then you will say, please reserve my book ticket for this train. Okay. And only some data you can see, the other things manipulation you cannot see. So how these all things you will do, and this how this database is doing all these things, that will tell you data abstraction. Okay, so the main purpose of the database system is first of all in which data models you are going to apply. Okay, and the second is how you are going to abstract the data, how you are reducing the complexity for the users to use your database. Okay, so the 2 points were there, data models and data abstraction. So first data model is so a collection of tools for describing data. So data we already know. I told Siddharth 19. Okay, so this is two data is there. One is Siddharth, one is 19. This is data. Second point is data relationship. So how this Siddharth and 19 is related to each other, that is called relationship. Okay. So data model will give you the tool where you can describe this is the data and this is the relationship between the database. That is, it is not only in the mind or in the conceptual only you are telling this data is there and this is related to that. If pictorially, if you want to show some person, maybe I want to make some website and I want to make some database, and I hired one person, please design one database for my this website. Okay, so he will tell me, okay, I will design your database like this, like this, like this. So if he will tell me verbally, it is not understandable that much. If it will show the pictorially. So data models will help you to show the pictorial version of the your database. Like if you are going to construct a building, okay. So before constructing the building, you will make some architecture one diagram. Like your building will be constructed like that. Okay, you will show in the diagram. And when the person who wants to construct the building is satisfied with the construction, like how you are doing, how the things are placed in the buildings and all, if they are satisfied, then you will start constructing that building physically. Similarly, for for database, first you will think how I will make the database, how I will optimize the database, how I will store the data, and these all organizations you will decide. Then, when you want to show that design to the user, how you will show using the data models. There are so many data models are there. You use some one data models according to the requirements, and then using that data models, you can show the person like how my data will be stored. Okay. So the third is data semantic. Data semantic meaning is the meaning of the data. What is the meaning of this data? Okay, so that also you will have some tools to define the meaning of the data. And the fourth one is data constraint. Data constraint is like some kind of rules you want to impose on data. Like for name, you accept only characters, not numerical values. Okay, so this is one kind of constraint you have given. Okay, so there are lots of constraints are there in database to make the database in consistent state. Okay, so there are lots of constraints that also we will study in a one part of our module. Okay, what are the different database constraints are there? So one constraint I can tell you that is primary key constraint. I have just given the name, but we will see the description. I think in module 2 we can see the description what is primary key. Okay, foreign key, primary key, candidate key, so many keys are there. These all are the constraints on the database. So that whatever as multiple users when they will use the one database, so our database will be in the consistent state that like if we are retrieving some data, that data should be correct. It should not be if I will retrieve, I will get different data. If some other person will retrieve, that will get different data. Okay, so like if I am booking the train, I am seeing in my laptop it is showing yeah 5 seats are available. In their laptop, if they are saying it is showing only 1 seat is available. How it is possible? That is inconsistent state of the database. Okay, to make sure that database should not be in this inconsistent state, we will use so many different kind of constraints or rules. Okay, so how you will define
Ma'am,
that? Yes,
Mabruk is waiting outside, ma'am.
if they will come late, then how this class will happen? Okay. So my voice is not breaking. Is it fine? Are you able to understand?
Yes, ma'am.
Yes, ma'am.
Okay, okay. So in any point of time, if you have any question or doubt, please ask me. Okay, so first point we have already discussed. What is the means data models are the collection of tools. So there are so many different types of data models. So one is relational model. Okay. So in relational model, what we will do? we will store all the data in our table. So many tables we will make. See, like if people will come like this, then how I can continue my class? Every time it will get disturbed. Mabruk, you already joined. I think you were the first person who joined the class. Again, you came late. Okay, so I was telling about relational model. Yeah. So in relational model, you will store all the data in the form of tables. Okay. In tables, you will have some columns and the table name will be there. So this is relation model. We will discuss mainly the relational model, and the second is entity relationship data model. So in this subject, we will discuss mainly these two models, relational model and entity relationship model, because that is the mainly most of the persons are using these data models only. But we have object based data model also, so it is mainly based on the object oriented functionality. So if you have you studied C++ in your last semester? Okay, then you would have aware of this object oriented concept like encapsulation and this inheritance. Yeah. Correct. Hmm. So this model, object-based data model, is mainly based on these properties. Okay. Fourth one is this semi-structured data model. If you will see, the good example is XML. XML is a language, okay, where you can design your website. You cannot design actually um, if you have placed picture. So if you want to do some decoration in your website, so you can use XML. Okay, so that is semi-structured, and the other models are network model and hierarchical model. Actually, in the previous time, mostly people were using network model and hierarchical model, but nowadays it is not useful because now the requirements has been changed. Now there are millions and trillions of data are there, so these models are not capable to uh, to hold and to manipulate this much of data. So only very few companies or very few databases are using these models, which are uh, which uh, uh, which are from so much years back. If they are still working, that then only they are using network and hierarchical model. Otherwise, if anybody who is going to start their model or if they are going to design your database, they will not use network and hierarchical model. Okay. So, in our subject, we will only discuss about relational model and entity relationship model. Okay. So, I'll just give you the brief example of this relational model so you can see the pictorial view. If I will say in the university database, okay, in the university database, one table is instructor table, where instructor information will be stored. Okay, and what information will be stored? That is their ID, their name, their department name, and salary. Okay, so this ID, name, department name, salaries are column, and the data inside the column is the row. Okay, so whenever we will study more about relational model, so we will use to say these are the columns or these are the features, and data we will say as a row. This is the first row, second row, third row. Okay, so all data will be stored in the various tables. So I have shown one instructor table, and another one is again instructor table has same ID name. Yeah. So second is department table. So in department table, what you are storing? Department name, building, budget, and so on. So many things you can store actually. Actually, in the real database, there will be so many fields will be there. 100 fields will be there, but we cannot show it pictorially here. So we are just showing you 4 and 3 fields. But in the actual database, there will be so many fields will be there or columns will be there. Okay. So these are the one sample example of relational database. And we will see here in the further chapters how we can define the relationship between instructor table and department table. And I can give you the one hint only. See, in the structure table, you can see department name, and in department also there is department name. So you can make relationship using this common column name. Okay, how we'll make the relationship and all everything we'll check later. Okay, so this is relational model we have seen. Now the next one is level of abstraction. So what we have seen here, data model and data abstraction. So data model we have discussed and we have seen one example of relational data model also. Now we are going to the second point, data abstraction. Okay, how you will hide the complexity of the data structure, what you are using, and how you are manipulating the data, how this all things you will encapsulate in one box. Okay, so there are levels of abstractions are there. Okay, so there are mainly three levels, that is physical level, logical level, and view level. So the physical level is a simple describes how a record is stored. Logical level will describe what data is stored in database and the relationship among the data. Okay. So, if I will take the example of you all have done C programming. Okay. So in C programming, you will have variable. Okay. So in variable, you will store some value. Okay. So if I have taken integer a equal to 3, so a is a variable. Okay. So how in the memory a is stored is it is called physical level. Okay, how it will take 4 byte or 2 byte, in which location memory it will stored and all. This is the information that physical level will have. Logical level will have a equal to 2 I have given. So 2 value it is having. That is called logical level. Okay. So what value it is stored, that is called logical level, and how you are storing the database in your space, like in our laptop we have 50 GB 100 GB data space and all. So how this memory is going to be used for storing our database. Okay, so that is physical level. And uh, how we are making relationship between the data which we will store in the memory, that is logical level. Okay, so you can take the example, uh, like type instructor equal to record. Okay, so instructor table we have seen already, relational table. Okay, so see, we are giving here what is the table name, how it is stored in how this instructor table will be stored, that will physical level will tell. Okay, logical level will tell I have one table name which is instructor, and that table name will have 4 columns. id will have the string kind of data, name will have string kind of data, department name will have string kind of data, salary will have integer kind of data. So this all information is logical level. Okay. How you are going to store this ID, name, department, salary in your memory, in actual memory, this is physical level. Okay. Now the third one is view level. So view level is application programs hide detail of data type. Views can also hide information such as an employee's salary for security purpose. So view level is a very important level. Okay. So I'll take the example of thesis ion. So in thesis ion, when you will log in, what information you can see, and when I will log in, what information I can see. Maybe whatever information you can see in the thesis ion, I cannot see. And what I am seeing in my thesis ion account, you cannot see. Okay, because I have the authorization to insert the marks of the student, but you don't have the authorization for that. Okay. So can you see that view level, different view level you can give according to the user. Which kind of user need only this kind of data. So, okay, we will show only this kind of data, even though that data, actually what I can see, what you can see. Whole data is stored in the database, one database, but only one particular view only you can see. And you also and I also only one particular view can be see. There will be only one or two database administrator will be there who has the full access of the database. They can see everything. Okay, who has designed or someone, one or two person. Otherwise, everywhere HOD will have their own level of data. Okay, like for we are giving the leave applications to the HOD and all, but you cannot see which faculty has given leave application and it is approved or not or something. You cannot see, but this all data is stored in common database. Okay, so view level is for security purpose. It's like whatever view is needed for student data, for faculty, for HOD, for registrar, for vice chancellor. So there will be different view level of the database will be there. Okay. So here there are three levels of abstractions are there. One is physical level, means we don't know how our data is going to store. Somebody is taking care of that, like how to optimize, how to use optimized way storage system so that we can store the record. Okay, some person will be taking, but as a user, I don't know how this data is storing. Logical level, some person will be there that will organize the data. Okay, we will store this information in this table, this information with this table, so we can relate this data easily. And if we want to retrieve this data and something, they will have so many things in their mind and they will make the logical connection between the data. Okay, that also I don't know, because as a user in a TCS Ion, I don't know how logical level they have used to connect the data. Okay, now, in the view level, you already know whatever you can see in your website, that is the view level. Only this thing. Okay. So, if Pictoria, if you will see, that is the architecture of a database. First of all, physical level will be there. Above that, logical level is there. And then there will be so many view levels will be there. So, this one thing we can observe from this picture is physical level will be only one level. How physically data is stored in our memory space, that will be only one configuration will be there. Okay. Similarly, on top of that, how we are going to store the data in this space, we are making the logical level. And that logical connectivity also will be the one level. Means only one kind of configuration you will be using. Okay. Then there will be different kind of view level, because the same database you are also using, I am also using, other person is also using, just the view level is different. Okay. So this is the database architecture. It's not a full architecture. We will see in the in some other couple of days, like what is the full structure of the database. But this is a very abstract way of structure. So we'll see what are the physical level components mainly we are using to design physical level of database, and what components we will use to design logical level of that database. And for yes, 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 level, there are, yeah, there are so many architectures is there, but only one architecture you will use. Okay, if I'm saying you please design like for online shopping, there are Amazon, Flipkart, so many are there, but from one website only you are going to purchase, either Amazon, either Flipkart, either Myntra or something. So for physical level, there are so many structures are available, but to design your database, you will use only one structure. Okay, so, so okay. Any other question? Thank you for asking the question. Yeah. Anyone who wants to ask? Who has asked the last question? Okay. Yeah. Okay. Okay. So I will continue. What is the time? 2:47. Okay. Okay. So view level. See, for logical level also there will be so many logical level. Uh, Logical level I can see if I will ask you to program Fibonacci series. Okay. Or factorial of a number. So you can design that program using function also, using loop also. Okay. The purposes get fulfilled, but it depends on the requirement. A person wants to implement factorial program in the terms of function or in the terms of loop. So there are so many ways to write the code to get the desired output. Okay. But at a time you will be using only one program. You will be not using all the levels. Okay, so for physical level, there are so many configurations are there to optimize so many things. But it depends. In your system, you want to optimize the space, or in your system, you want to optimize the time. If you want to optimize the time, so sometimes what happens, the space will be more you will be using. If you want to optimize the space, so sometimes that will take more time to retrieve the data. So it depends on the database designer and the user who wants to design this database. They should be clear with the requirement. You how which kind of database you want and what means what properties you want. According to that, we will design the physical level, then logical level, and then view level. Okay. Now the next topic is instances and schema. Just a minute. Instances and schema. Okay. So what are instances and schema? So, see, in first module, we are only discussing about the terms what we are using uh, in terms of DBMS. Okay, because if you will study C++, there will be some common terms. That is, if I will say inheritance, so you know what is inheritance. If somebody doesn't know what is inheritance, so they will not get the concept whatever I am using inheritance word. Same here for database management system, some common words we are using. So that word meaning only I am telling. So what is instances and schema? So many times I will use I have made this schema, I have made this schema. Suppose this is the instance of this database. So you should know what is the meaning of this thing. Okay, so module one is the introduction part. Everything I will tell in the meaning. Then only will come by step like how to understand the database. Okay. So the next is instances and schemas. The first point is similar to type and variable in programming language. Schema, the overall design of a database. Okay. Logical schema, physical schema, and instance. So in a simple word, if I will say, schema is the architecture. How you are, and this word we will use in the logical level actually. So in the logical level, how you are going to structure your database, how you are going to relate the data, and how you are going to make the relationship between the database, that is called the schema. Okay. So logical schema is the database consists of information about a set of customers and accounts in a bank and the relationship between them. So they have just taken one example, like we have bank. Okay, in bank, logical schema is like how they are going to get relate customers and account. How you are structuring that, what properties you are going to use the customers and accounts to make the relationship. And later on, when I need some particular information, so easily you can understand with that relationship and you can give me the data. Physical level is the physical schema is it's like how you are going to same like physical level. logical level is there now. So for physical level, how you are structuring the physical thing, and for logical level, how you are structuring the thing. Okay, so these are the schemas. The schema is mainly the architecture. Architecture means, if I will tell, for university you have to make the database. So you will tell, okay, I will take 50 tables. I will use 50 tables. What that 50 tables will be there? How the relationship between that 50 tables you will use. Somebody will say, no, I will use 100 tables. Somebody will say, no, I can design the database in 25 tables. Then within 25 tables, how you are going to connect all the tables, that every kind of query, every kind of information you can give me. Okay, so these are the schemas, how you are going to design. Okay. Instance. Instance is very simple. In a particular time in that schema, what data is available. So if I will take the example of customer and account, you just visualize customer table is there, account table is there. So what information is particular in this time it is there? How many customers are there and how many customer has which account and all. So in a particular time, what information is there? It is called instance of the schema. Okay. Okay. So next is physical data independence. So what is physical data independence? The ability to modify the physical schema without changing the logical schema. So, okay. So, it is a very small point. Like, you have asked one question, Hariram, that there will be only one physical level schema. So, I told there are so many architectures are there. Okay. So, so maybe you have used one physical level of architecture, and top of that you have made logical level of uh, logical level schema. Okay. Now maybe you want to change the physical schema. Okay, but it should not change the logical schema. Okay, so that independence should be there. Your logical schema will not be fully dependent to the physical schema, that if sometime of point you will means you will feel like, no, I think this physical schema should be changed like this. So if you will do that change, then your logical schema should will also affect. Okay, it should not happen. It should be independent. So we will try to make our database where the physical structure and the logical structure should be very less connected. So if any changes will done into the physical schema, it will not affect to the logical schema. Actually, it is a very difficult task. So many research is going on this at this point of this point in this area also. Like how we can design the database which will be very less connected with the physical and logical. So if any change we will do in physical, it should not affect the logical. Okay. Hmm. Now the next one is database language. Okay. So this is the very important point. Actually, module 2 is mainly depend on this database language. So database language is used to communicate with the data. Okay. So a database system provide a data definition language to specify the database schema and a data manipulation language to express database queries and up. I think only till database queries will be there. Should not be up. I'll just change. So database language. So there is only one language we are going to. Not I'm saying one language, but there will be language. It is there. There are different language are also there. Okay. So to communicate with the database. So there are two parts of language. One part is data definition language. The second part is data manipulation language. So these are not different language. Actually, this is a one language only, but that language has been divided into the subcategory. That is data definition and data manipulation. And by the word, if you will understand, data definition means you will define the structure, how to store the data. So to define that structure, how to store the data, this language tools you will use, or this language functions you will use. Then, when you have designed the structure of the data and you have now you want to insert the data on that structure. So to insert, to delete, to update, to communicate with that data, you will need data manipulation language. Okay. So the two parts is definition is defining the structure, like what is the table name, what fields it will take. This is the data definition language. So how you will define what is the name of my table, what will be the fields of my table. Like if I'm making instructor table, so my table name will be instructor and it will take ID, name, department name, salary, and ID will be the integer, the name will be the string. How these all things you will define by using data definition language. Okay, there are so many mm, what I'll say, tools are there or some functions are there which you can use to define this. Okay. The second is data manipulation language. Once you have defined this is the instructor table and ID, name, department name, and this I will be storing. Now, the first entry you want to do means Preethi Verma, the ID is this, the name is this, and the department is CA, and the salary is this. This data, how you will insert this data? You will use the tools from manipulation language. Okay, there are so many functions are there which will give you the possibility to insert the data, or sometimes, yeah, anybody who wants to say something.
Ma'am, Jamil is waiting outside, ma'am. He has some network problems, it seems.
Okay, okay. So 48 is there. Okay, so I will take a screenshot on this only. So I can also show it later. Hmm. So yes, data definition and data manipulation. I think you would have got some idea about what is data definition, data manipulation. This is not the different language. This is the part of one language only, but this is two different parts. One is defining the structure of the database, and second is to manipulate the data which you are going to insert in that structure. Okay? So there are some more description about data definition language and data manipulation language. So what we will do, we'll just complete this data manipulation and data definition language. So then SQL query will start next class. Okay? So only two slides. So one is data definition language. So we know already data definition language is to define the database schema, and we know what is database schema means architecture of the database. So example is create table. The table name will be instructor. Here you have to give the after create table. So create table is the function that you have to use or the name you have to use. Okay, then compiler will understand that you are going to create one table. The table name is instructor. Then after you will write this bracket. After the bracket, the compiler will understand now you are going to define the fields in that instructor table. What will be the column name? So the first column name is ID, and after that, if you will write character 5, means this is the type of the data which it will take in ID. Okay. Then the second column name is name, where they will insert the data of the type of varchar. Okay. So character 5, it is written means at most 5 character it can take. Varchar is at most 20 it can take. Varchar is like combination of variable and character you can take. Okay, name. Department name also variable connection means combination of variable and character you can take up to 20 characters. Okay. Salary will be numeric A2. That I will define what is numeric A2. Okay. So this is the structure of one table. In database, there are so many tables are there. Okay. So this is the example only how to define one table and their field. See here, you cannot see any data. Data is not there. You are just defining, I will save the data in terms of these fields. This is the structure you have defined. So data definition language is giving you the possibility or giving you the tools to create the table. Okay. Second point is DDL compiler generates a set of table templates stored in data dictionary. Okay. So already in data dictionary, so many tables structures are there. So that also you can create, take template. You can use already defined templates also, or you can create your own table also. Data dictionary is mainly it contains the metadata. Metadata is what? Data about data. Means um, like um, you have created this table. If we will go the example again, create table instructor. Okay. ID. If in ID I have given some rules also, some constraint also, then that constraint will be stored in data dictionary on this data. So that is what data about data. Data is ID for data dictionary, that this is the one field of the one table. This field has any constraints or rules you are imposing on that, that will be also stored in data dictionary. Okay. So database schema, integrity constraint, authorization also. Maybe I will tell like in this table I am storing 4 features, but if user one will come and it will get, if it wants data, so user one can take only ID and name. It cannot see the department name. So if this kind of authorization also we have imposed, that will be also stored in data dictionary. Or maybe the other employee cannot see the salary of the other person, so we have imposed the data that if the person's ID is similar to the salary that they want to see, means that person is seeing their own salary, that is fine. But if the person is trying to see the other salary, don't give the authorization. So this kind of constraint we have imposed on that. So these all constraints and all information will be stored in data dictionary. Okay, how to impose the constraints and all, this data definition language will give the tools for this. Okay, so only one tool you have seen till now, create table. That bold letters you can see, create table, and these are also the defined data types of the database, which data types you can take. So there are so many different data types are there, that we will also discuss in module 2. What are the different data types we have? Like in C, we have integer, float, double, so many data types are there. So here also we have some different kind of data types. We will discuss that. Okay. So the next point is data manipulation language. So is by the word manipulation, you can understand means you are going to work with the data. Sometimes you are going manipulation can you addition, subtraction. These are comes under the manipulation. Okay. So how you will do? So first manipulation is that if you want to insert the data, then how you will insert the data. So there is one tool is there, insert data into this table. So we'll see all this thing in SQL. Okay. Yes. Okay. Okay. So so the first point in this, language for accessing and updating the data organized by the appropriate data model. So data model is the architecture. So in that architecture, if you want to access some data, update some data, actually insert things should be also there. Language for inserting, accessing and updating the data. So there are mainly two types of data manipulation language, that is procedural DML and declarative DML. Very small difference is there. Somebody's mute is sorry, sound is not unmuted. Please unmute yourself. Kabir,
అక్క నన్నే ఒరే రూలతో ఇలా నా కాడ ఇస్తూ అంట కాడ ఇస్తూ
I don't know he's talking to me or someone else. Okay. So two types of DML is there, procedural DML and declarative DML. So procedural DML requires a user to specify what data are needed and how to get those data. So in procedure, a user will write their own code like I want this data and how to get this data I will write. And declarative ML is like you will just specify what data you want. You don't have to tell how to get this data. Okay, so these are the two different. We'll see how to write queries for ourselves, a user, how can write the queries, or some already defined functions how we can use. So obviously declarative DMLs are usually easier to learn because we don't have to know how to get the data. We just have to tell what data we want. Okay. So declarative DMLs are also referred to as non-procedural DML because there will be no procedures will be there. You just have to define what data is needed. So no procedure is there. So procedural is that you have to give the procedure to how to get the data also. Okay. So the portion of a DML that involves information retrieval is called a query language. Okay. So if you want some data, you are not going to insert or updating. Now you want some data from database. So uh, the code you will write, that code will be said like a query language, or the portion which will give you that data from the database. That portion will be called query language. Means you are doing query. You have done some query and you get some answer out of that. You get some data from that. Okay, so it's just a one word is there, query language, because most of the time we will see in the SQL how to write the query language. If I will give you some scenario and I will say you please write this query to access the student data whose name is starting with N. So you are going to retrieve the answer in some terms of table. Okay, so this is the query language. Okay, we'll discuss about this query language in details also when we will discuss about the architecture of the database in details, and when we will be doing some SQL queries on the in our system. Okay, so I think from next week we can start our SQL query, because now we can start the next slide is SQL query only. So we'll see how to write the queries, and I will give you some simple queries also how to run that queries, and you can also write by your own self. Okay. Okay. So in this point till here, anyone has any question? So this is the end of the today's session. We'll continue on Tuesday. How many slides are there? Okay. Ah, yes. Ah, yes. Tell me. Oh. Hmm. Yes. I think it will be only view level. Yes. Because the logical level is like how they have organized the data. So in that you cannot see how they have organized the data. They will just give you in some format. Okay, it is not particularly how they have organized the data. They will not show you. Okay, you want Twitter data, they will get that data. They will make some format, maybe already defined format will be there. In that format only they will give the data. So it is only view level. It's not physical, it's not logical level. Okay. Any further question means if you are not satisfied with the answer. Yes, yes, yes. They cannot give you access of the database that you can see the logical connectivity and all. No, they will not give. Yes, yes. Okay. Anyone else? Thank you, Hariram, that you have asked the questions. At least you have made this session little interactive. And I'm happy that you are studying sentiment analysis and all these all things you are doing. No, that's fine. Yes, yes. Actually, you are diving into the data science. So data science is the upper level of database. So yeah, yeah. So it's good. Okay. Okay, so I think we can take the attendance, but again, there's a problem how to take the attendance. Class advisor, can you tell me who all are not present? Because 48 are present, only 4 persons are not present. Yes, Vicky, are you going to tell?